So I'm Maurice. I'm co-founder and co-CEO of Farming Revolution. We're a German company that makes autonomous weeding robots with currently 40 robots in operation. You have to get the headset over there. And I want to start the talk by talking about something that we all agree on. We all want to use as little herbicide as possible. So everyone in this room, you and me and farmers, we're all consuming agricultural produce. And of course, we would not like to have too much residuals of herbicides in our produce. So in general, the way this works, for, let's say, baby food, you go organic. If it's, for example, something you consume directly, like lettuce, you're going to go for organic. And then if something organic is not available or it's too expensive, you're going to go for non-organic, but of course you'd like to have as little residuals as possible. Okay. As well, we don't want too much residuals in the groundwater because of the negative consequences that it has when it accumulates there. And that led to a situation where there's a lot of pressure on farmers. So pressure from the politics, pressure from the consumers to reduce the use of herbicides. Okay. But farmers don't like to use herbicides. Right? They don't use herbicides for the sake of using herbicides, but because they don't have any alternative. So actually for farmers, using herbicides, that means that we degrade the quality of the soil, which is a problem for future production and for the future generations. And as well, it is a problem to keep the herbicides effective. So it's like if you use antibiotics every day, after a while you're going to have resistant bacteria and the antibiotics stop working. So it's a big problem. So in the same way for farmers, using too much herbicides leads to resistant weeds, and we don't want that. So we want to use as little herbicide as possible to also keep the herbicides working in the future. So that's something that we all agree upon. Let's use as little herbicide as possible. So how is it possible that still, if you look at today, the weed control, it's a large majority, like 90% in the EU is using selective herbicides. And I think it's interesting to look at what we were doing before. Oh, this is me exiting the presentation. We can make it large again. Perfect. So I must have pressed the wrong button. So basically, before we had selective herbicides, we used a combination of hoeing machines between the rows and then manual labor on the row. So we're removing the plants by hand. And I think we're all very happy that we got selective herbicides, where we're able to have more agricultural production at lower costs. A lot of people could go out of the field work because it's a very hard work, repetitive, difficult job, and use selective herbicide instead. So that's something that we're really happy about. But we believe it's now time to go into the next era, which is using selective weeders. So here, for instance, you see our system working in celery. And you see we're basically removing weeds not only between the rows, but also on the crop row, mechanically. So using the same setup as we used to before the 1940s, but without using the manual labor, because from this room it would not be possible that a big portion of the room would roam the fields and remove things by hand manually. Now the question is, how come those solutions are appearing now, or in the last 10, 20 years, and not beforehand? Why couldn't we do this beforehand? And the main game changer is the use of AI. So what you see here is sugar beet in different stages. And basically, if you look at a field, usually you have around 100 square meter, 100 weeds per square meter, and you have a couple of crop plants, and you have to remove the weeds. Why? Because they compete with the crops, and if you don't remove them, the crops don't develop as well, and in many cases, you cannot harvest at all. And the way the selective herbicides work is that it's basically a plant poison. We apply the herbicide over the field, it kills the weeds, and it doesn't harm the crop as much as it kills the weeds. It still harms them, but doesn't harm them as much. And so it's a very good solution to remove the weeds. But now that we have AI, we can recognize the plants. And as the guy who presented me at the beginning said, already speaking here in 2016, already saying that we have recognition of the plants. I mean, now it's like almost 10 years later, those systems are very, very robust. So just in our case, we've been on thousands of fields, more than hundreds of plants, different countries, different soil types, day and night. It's always very reliably recognizing different types of weeds, different types of crops, and so on. So once you recognize the plants, you can say, okay, those are the plants, those are the weeds. Now I can remove the weeds with a selective weeder. So for example, what I've shown you before with a mechanical tool in the celery, but also you can use a chemical that you only spray on the weeds, or you can use a laser that only targets the weeds. And basically, so you can have different solutions to target the plants. And I want to repeat here, this is not like a research project or something. This is really something that's really reliable. And it has to be 100% reliable, because if you make a mistake, you kill the wrong plant, and we don't want that. Here, just to give you another example, another crop, before was sugar beet. This is parsley. And so you can see that it works for different types of crops. We believe that there will always be combinations of different solutions, okay? So here what you can see in the first video is the system working. Sorry for the sound feedback. This is what am I doing wrong here, the sound? This is a system working in cauliflower. And you can see that here we just use the robot. It removes as many weeds as possible, very close to the plant. So this is really excellent result for the system. You might have a few weeds left very close to the cauliflower plant, but that's not really a problem because in the way the cauliflower is planted, it has a head start. And then the way it's harvested, if you have a few weeds remaining, it's not a big deal, right? So we believe for cauliflower production, for instance, we can remove the herbicides completely and only use our system. Also, if you're an organic farmer, you can remove as many weeds as possible with our solution. And then if you have a few weeds remaining, you can remove them by hand or just leave them. And it's not such a big deal. You're an organic farmer, you can sell the produce for a higher cost because it's organic and has no herbicide residuals. In the majority of cases, however, leaving even a few weeds is not an option. So for a conventional farmer that has very large fields and has no manual labor, it has to be 100% clean the field. Like it's not possible to even leave a couple of weeds. So in those cases, what we have is a system which is a combination of mechanical and herbicide. So it's not so easy to see on the video. Now it's there. It's going to come back in a minute. So there we have a nozzle, and we apply herbicide only on the spots where we cannot go mechanically because it's too close to the plant. So we can hurt the plant, which maybe it's too small, or if the soil is like hard and breaks apart, it's better to use a herbicide and make sure there's no weed left, because for those farmers, this is just not an option. And we have like more than 10 robots that are running for conventional farms, and it's like 100% clean field after the robot passes by. The last system, which you can see on the last video, is a laser solution that we've integrated on our robot. It's not for sale yet, it's more of a prototype. But the cool thing about laser is, of course, we don't use herbicide, and we can still target weeds which are a bit closer to the plant than with a pure mechanical solution. It has some inconvenience though. For instance, you have to see the weed and target it. So if you see the first video where the cauliflower is a bit bigger, you can imagine if the weed is hidden underneath the leaf, you cannot see it and it's hard to actually target it. So in the first case, I think it just doesn't make sense to use a laser. In some cases, it's very good. It has some other drawbacks, for instance, that it's very slow, so slower than mechanical, and it's very costly. So both upfront costs and running costs are very expensive for laser. So here again, it makes sense. Use as much mechanical as possible and only do laser in whatever cannot be done mechanically. So this is what we believe will be the three types of approaches, always as much mechanical as possible, and then combine with manual labor, combine with chemical weeding, or combine with laser weeding. So there's one thing which is in common for all those solutions, is they have to run on a robot. And that's what we hear at FIRA, and not somewhere else today to present this. You can see one of our farming GTs. And since those types of work with the in-row weeding is a slow process, and you still need to achieve a high acreage. You can only do that if you have an autonomous solution. So for instance, a robot, when we use it for conventional farms, which are larger, where we need to do more acreage, with a 3-meter width, we do 10 hectares in 24 hours, which is already quite a good size. And we have some farmers who are very big, for instance, in northern Germany or in Poland. And if they say this is not sufficient, we just put several robots. So we can put, let's say, 3 robots and have 30 hectares in 24 hours. So this really can scale with a number of robots. And we have a solution for all types of field sizes. The other reason why it has to be on a robot is the weight. So we always have issues with rain events during the time when we have to do weed control. And if you have a very heavy hoeing machine with 18 rows and a tractor and a weight in front, you're quite easily, quite fast at 12 tons or more for the full setup. And we've seen last year, where it rained a lot, that many of those systems were not able to enter the fields because it was always too wet. But the robot could enter much, much more often, because it's only 2 tons, than such a heavy solution. So we believe that it has to be on the lightweight robot solution to be able to really scale and not work some of the time, but work really every year and keep the fields clean. So one thing that's very important for us is to keep the system as simple as possible. So in our case, everything which is software related is done remotely. So most errors we don't notify directly the farmer, but first notifies us so we can fix it. In general, the farmer doesn't even recognize or notice that there's an error. We don't try to reinvent the wheel concerning mechanical solutions, so we use robust tractor parts, make sure that the parts can last for a very long time. We make sure that there's low maintenance, so for instance, we don't use hydraulics, we use electric motors. In the design, we make sure that everything can be replaced easily, ideally by the farmer on the field or by the local partner that can help him out or her out, but try to make it really accessible and easy to fix. And the last part, which is very important for us, what we have seen, we don't want the farmer to change anything in the way they prepare the field. So we haven't seen a field that we're not able to treat with our system because it's very flexible in the way we can add the field and so on. There are ways to simplify it if you change it a bit, but we don't want to have a field where it's just not possible to go. So for instance, we don't require the farmer to seed with a specific system. Can seed with GPS, with no GPS, can seed in pockets with the seeds being together. It can transplant the crop. We don't care. A robot is able to do all of those different types of fields. So our mission as Farming Revolution is to simplify sustainable agriculture. So we don't want to make something overly complex. We want to make it affordable through autonomy and through scale of production. And we want to make a solution for every farmer. So not only for organic farmers, it's already great if we can help out organic farmers, but we want to also address conventional farmers. And that's why we have 2 products. We have the Farming GT that's running in organic fields. So to be honest, it's the majority of the robots we've sold so far. So that's mechanical weeding as close as possible to the crop, saving 80 to 100% of manual labor. So in some cases, the farmers use it and have no manual labor. Most cases, they still have some manual labor, but they can already save 80%. But what does it mean saving 80%? That means with the same workforce of manual labor staff, I can do 5 times the acreage. So we think that those kind of systems can really drive a progression of the organic acreage. And of course, using 0% herbicide. And the second solution for conventional farmers is we're doing as much mechanical as possible and only use herbicides in the area close to crop. So we save at least 80% herbicide, which is already really, really good. In some cases, we save 100% herbicide. But we have 0% manual labor, which is a must-have for conventional farmers because they just don't have the people that could remove the remaining weeds. So this is why we have the setup for the 2 types of machines. So the robot, you can order it. So most robots are running in rental or in sales. All the new robots that we produced are being sold. We have a production batch which will be delivered in the next weeks. Those are already all sold out, unfortunately, but we have a new batch coming this summer. So if there are farmers amongst you that are okay with having a system in July, August, feel to order it. There's a form on our website and we will send you a quote or just talk to me. I also speak French if there are some French farmers in this group, and we can hopefully get a farming GT on your farm. Thank you.
Merci beaucoup,
Well, thank you very much, Maurice, for this presentation. Maybe there are questions from the public, and in which case I will circulate my microphone. Can you please introduce yourself? Good morning, Maurice. I have a question for you. I come from Zikla. We also manufacture autonomous robots. We do tillage and who. I have a question about the navigation system. Are you using RTK? Are you using cameras? How do you navigate and guide your devices? Well, thank you for the question. What is the technology?
So basically, we have a combination of GPS and of cameras for navigation. So for instance, we use the camera, the AI for recognition of the plants, and then the row following based on that system. So for instance, if you have a very green field with just a lot of weeds, it will recognize the rows and be able to navigate well. We do use RTK GPS, but with correction data. So in general, we do not use a base station, but correction data over the internet. We can, however, install a base station, just use that information for navigating. If there is no correction data or there's a GPS problem, the robot can continue driving. It has to be manually ignored that there's a GPS issue. It will continue following the row. It will continue the weeding. Cannot do turns, but it has to be supervised. But there's always an option still to make the robot run or in an indoor environment for demo, something like this, even if there's no GPS correction data.
Thank you. Is there any more question? Yeah, here. If you can introduce yourself, please.
Sebastian from Nature Robots. My question is it necessary that there is a person next to the field observing it? So regarding the machine regulation of the EU, for example?
So there's no person that has to stay in the field. So usually you set up the field and maybe, it depends on the size of the field, but maybe half an hour, 1 hour. And then usually you check like once a day to see that everything's okay. You have to refuel. So we have a system with a battery plus a diesel generator. So you have to refuel from time to time.
So there's no law on that?
No, so we follow the machine directives, all the norms that apply to this. It's fully unsupervised, it runs day and night, and has been already for a couple of years.
Thanks.
Thank you for this information. More question? Yes, here. If you can introduce yourself, please, yeah.
Bonjour, Paul Vaillant.
Good morning, Paul Vaillant. You said that you can purchase 2 to 3 robots. For a robot like that, can you use it in a 12-row farm or a 6-row? Would it be possible to use it in twice 6 rows?
Today, we have a max width of 3 meters. And the reason for that is twofold. One is makes the transportation easier. And a second reason is for being lightweight. So as of today, we recommend every farmer that says, I want 12 rows, just use 2 robots and it will be more flexible. It will be less pressure on the fields. So that's the current setup that we're looking at. We also have farmers using 3 robots on the same field. So a combination of robots works, but we don't intend at the moment to have wider robots.
And if I understand well, it's just because question of weight.
Yeah, the main question is weight. And it's like the whole system is designed. So compared to other systems that say they're very flexible for different types of tools, we have a system which is specific for the weeding task, and everything is optimized for this. With the specific tools, if the tools get clogged up, we recognize, we free them, we observe the whole setup. It's a system that can work day and night, and no problem can occur at 1 a.m. and destroy anything. So that's why over time we really developed something which is, as a whole, works well for autonomous driving. And then there's things like, for instance, the size of the battery and of the fuel tank, or the size of the herbicide tank. Everything is made to be run as a 3-meter machine. So if you had 12 rows, for example, you would need a bigger tank. When the machine is heavier, then you might need heavier, stronger motors. It just makes more sense to scale the acreage or the output with the number of robots than making a wider robot.
Okay, thank you very much. We have to close now the presentation.